Welcome to the students. Dear students, in this session, we'll be seeing the preliminaries and basics of the vectors. In this session, I'll be trying to clarify certain doubts which are commonly felt the students at the time of usage of the vectors. The concept of vector is very much common and it is very widely used while solving numerical problems in the physics. These preliminaries regarding the vectors will be very much helpful while solving the problem. So I'm going to share certain videos with you. Please be with me. Okay, welcome again into the session of the preliminaries about the vectors. As in the screen, you are seeing there are the two vectors, vector A and vector B. These two vectors are drawn by certain arrows, and the two vectors are having their tails coincident at one point. In this case, if you want to add the two vectors, the sum of the two vectors can be obtained by drawing the parallelogram. Consider the two vectors A and B. They make some angle 60 degrees between them, and we have to add these two vectors. In order to add the vectors, you have to construct one parallelogram. Here, while adding the two vectors, several questions may arise. For example, the first question, whether to use the triangle law or to use the parallelogram law of vector addition. Generally, the students are in the state of confusion, whether the triangle law of vector addition to be used or the parallelogram law of vector addition to be used. Similarly, the second question, how is the magnitude of the resultant written? You have added the two vectors A and B. The sum of A plus B has got certain magnitude. And if you want to write the magnitude of that vector, the sum of the two vectors, how do you write the equation? Here, the two versions of the equations are shown in the slide. The first version of the equation is having positive term, the positive term at the third place, that is a square plus b square plus 2ab cos theta, while the second equation is having the negative term, a square plus b square minus 2ab cos 60 degrees. So the students are generally in the state of confusion, whether the symbol plus to be used or the symbol minus to be used, and under what situation the symbol plus is used, and under which situation the symbol minus is used. So all these things will be discussed in detail, and in this session I will try to make the clarification about all these difficulties. Now let's take these two vectors A and B. The vectors A and B are drawn such that their tails are coincident. If the two vectors are drawn such that if the tails are coincident, then their sum is found by drawing the parallelogram. The parallelogram is drawn if the two vectors are having their tails at the same point, and the diagonal of this parallelogram will indicate the sum of the two vectors. And the magnitude of the total of the two vectors, the sum of the vectors, is written with the symbol plus. A square plus b square plus 2ab cos theta. So this is done like this. We'll be seeing some another situation. This is the different situation. You see here, the vector A and vector B are given to us, and we are required to add the two vectors. In this situation, the head of vector B is occurring on the tail of vector A. In this situation, in order to add the two vectors A and B, you should not construct the parallelogram. Instead, you have to draw one line making a triangle. See, the red color line is drawn here in order to make the triangle. This red colored line is indicating the total of the two vectors A and B. Vector A plus B is represented by the red color arrow. And moreover, the direction of the resultant vector diagonally downwards. How do you decide this direction? When you are going to add the vector B and vector A, you have to go in the forward direction. You have started from the tail of vector B, you have reached the head of vector B. Again, there the tail of vector A started, and you have reached to the head of vector A. Then the journey is completed. Then the total resultant vector B plus A or A plus B is drawn from the tail of vector B to the head of vector A. And moreover, this equation says that A and B, when added, in the same way, B plus A will give the same answer. That means the addition of the vectors is commutative. Next, again, about the angle which is subtended between the vectors B and A. Here, the angle 60 degrees is subtended between them. When the angle is measured between the two vectors and the two vectors are not having their tails coincident, in that case, you have to use the negative symbol in the equation of the magnitude. At the bottom of this slide, you are seeing one equation which is a square plus b square minus 2ab cos 60 degrees. The magnitude of the resultant vector is written with the symbol minus. This negative symbol is written because while adding the two vectors, the tail and head are not coincident. The tail of one vector and head of another vector are coincident, whereas the tails of two vectors are not coincident. Therefore, the symbol minus will come. Now, collectively, the two discussions will appear in this figure. You are seeing here one figure where vectors A and B are given with their tails coincident. If you want to add the vectors A and B, where the tails of them, the tails of the vector A and B are coincident, you have to draw one parallelogram so that the diagonal of the parallelogram will give you the answer of the sum of the two vectors A and B. Next, if you join the heads of vector A to the head of the vector B, if the head of vector A and head of vector B are joined, as you are seeing here, the red color arrow is drawn in this figure. This red color arrow is one more diagonal. So, of course, in any parallelogram, there will be two diagonals. In this figure, one diagonal is drawn in green color and another diagonal is drawn in the red color. Every parallelogram, of course, has two diagonals. In this present figure, the parallelogram is having two diagonals. One diagonal is shown in green color and another diagonal is shown in red color. Here, the diagonal which is appearing in green color is shown by one arrow, and this arrow is indicating the sum of the vectors A and B. If we add the vector A and B, the resultant will be that diagonal which is shown in the green color. Similarly, if you take the vectors A and B and if you subtract them, the resultant vector will be B minus A, and that is shown by the red color diagonal. So every parallelogram has got the two diagonals. In this parallelogram, if two sides of the parallelogram are indicating the two vectors A and B such that their tails are coincident. In that case, one diagonal which is coming between those two vectors A and B will indicate the sum of the resulting vectors, and another diagonal which is coming in other direction, that indicates the difference of the two vectors. And here, in order to find that magnitude of the result vectors, you are seeing here the two equations. One equation is with positive symbol and another equation with the negative symbol. So uh, the negative symbol is arising because the direction of the vector A is totally inverted. There will be 180 degrees rotation if any vector is rotated through 180 degrees, then the vector will become inverted. That means the rotation of the vector through 180 degrees is equivalent to say that the vector is inverted or the magnitude is reversed. So for that reason, uh, the difference of the two vectors is obtained by the subtraction of the third quantity. And again, here you are seeing the two figures, the left side and right side. In left side, the two vectors A and B are drawn with their tails coincident, and at the right side, vector B is inverted. At the right side, vector B is inverted. When the direction is inverted, then that vector will be called as negative vector or minus B. Now, in this case, if you invert that vector B, the inversion of the vector B is nothing but the rotation through 180 degrees. So at the left side in the figure, you are seeing here the sum of the two vectors A plus B is indicated by one vector which is drawn vertically upwards. And the magnitude of the resultant vector is written as A square plus B square plus 2AB cos theta. Now, if you come to the right side, there is a little change. The change is occurring only in the vector B. Here at the right side, vector B is inverted its direction. So here, a little change which is coming into the right side figure can be expressed in two different ways. Number one, you can say that the polarity or the symbol of vector B is inverted, or the same change can also be expressed as the angle between those two vectors is changed through 180 degrees. That means if you incorporate this change, then you will get the resultant answer. At the left side, you are seeing a figure where the two vectors are having their tails coincident. And if you want to write the magnitude of the resultant vector, you can write the equation as A square plus B square plus 2AB cos theta. Now, in order to write the magnitude, in other case, at the right side, you have to incorporate the change in this way. Number one, either you have to change the polarity, change the symbol of vector B, or without changing the polarity of the vector B, you have to change the angle, you have to increase the angle through 180 degrees. And both of them are going to give the same result. And the result is, of course, A square plus B square minus 2AB cos theta whole root. So all these things I will again explain in taking the different figures. Please be with me. Okay, let's take this figure. Here in this figure, the vector A and vector B are shown. Their tails are coincident and the angle between them is 60 degrees. Of course, the angle is always measured in the anti-clockwise direction. And the measurement of angle is always done when the two vectors are having their tails coincident. One additional thing I'd like to add here, that the student should be aware that when the vectors are drawn in the form of arrows, you are permitted to change the location of the vector. For example, here, vector B is here. I will take this vector B like this. This is vector B. It is permitted to change the location like this. It is allowed. Now, in this situation, the tail of one vector is coming on the head of the other vector. And in this situation, if you want to add the two vectors, you cannot use the parallelogram law of vector addition. Instead, you have to draw one triangle. So how do you draw the triangle? You'll draw the triangle like this. I'll show you this way. This is the resultant vector. This is your answer. The red color arrow is showing you the sum of vector A and B. See, this is the triangle law of vector addition. Triangle law of vector addition is used when the tail of one vector is coming over the head of another vector. And again, the parallelogram law of vector addition is used when the tails of both the vectors are coincident at the same point. Now, I will show you here again how the parallelogram law of vector addition is used. Now, as you know that shifting of vectors is permitted. I'll take here the copy of this vector B. This is vector B. Okay, I have taken this vector B. I'll make copy, paste. This is again vector B. Yes, of course, this is vector B, right? This is vector B. This is vector A. So vector B I have shifted here. As you know, shifting of vector on the screen is permitted. You have to utilize this permission. Yes, this is the vector. And of course, the resultant vector I got like this. This is the answer vector when A and B are added. Again, let me take vector A as like this. This is vector A. I'll take this as vector A. I'll copy it. And again, I will use this vector here. See, it is reaching at the same place. Of course, this is vector B. Vector B is this. And you know, vector A is this. And vector result vector is this. This is the resultant vector. Now you can see here, this is one parallelogram, and this parallelogram is having one diagonal in red color. This diagonal indicates the sum of vectors A and B. In this figure, also you are seeing the two triangles. One triangle is upside and other triangle is downside. Using the triangle law of vector addition, also you can find the sum A plus B. In order to use the triangle law of vector addition, it is necessary that the tail of A is coming on the head of B, or head of A is coming on the tail of B. If this situation arises, then you have to use this triangle. So triangle law of vector addition is used when the tail of one vector is coming over the head of other vector and vice versa. In that case, you will be using the triangle law of vector addition. And parallelogram law of vector addition is used when the tails of the two vectors, you see here the tails, the tail of vector B, tail of vector A, these two are coincident. In that case, you have to construct this total parallelogram, and the diagonal of the parallelogram is going to give you the answer. Right. You can see here, vector B, vector A, these two vectors are having their tails at the same common point. Then the resultant of these two vectors, if you add, is shown by this green color arrow. This green color arrow is indicating that sum of the two vectors. And another diagonal is also there, this red color diagonal. This red color diagonal is indicating the difference of the two vectors A and B. So every parallelogram has got the two diagonals. One diagonal shows the sum of the vectors and other diagonal shows the difference of the vectors. Let me take this figure. See here, the three vectors are there. Vector B, vector A, and the sum of these two vectors, A plus B. In addition to this, I'd like to show you another example where we can use the parallelogram law of vector addition and triangle law of vector additions. These two are used. So, dear students, in summary, again, I'd like to repeat you the same sentence, that whenever you want to add the two vectors, you have to see whether the two vectors are having their tails coincident or not. If their tails are coincident, then you construct one parallelogram, and a diagonal coming in between from these two vectors will be indicating the sum of the two vectors. If the two vectors are drawn such that the head of one vector and the tail of other vector are coming on the one point, then you have to construct one triangle, and that the third side of the triangle will give you the sum of the two vectors. Now, I'd like to share one slide here. Suppose vector A and vector B are added. When you are adding these two vectors, you have to see the angle subtended between them. Suppose theta is the angle subtended between them. Now, you want to write the difference of the two vectors. In order to write the difference, for example, B minus A, here this figure is showing you. I hope Okay. The sum of the two vectors A and B and the magnitude of the resultant vector is written as A plus B. The magnitude of that vector is written as A square plus B square plus 2AB cos theta. Now, you want to write the magnitude of B minus A. That means vector A is reversed. Reversal of the vector A is written by the rotation of the vector through 180 degrees or pi radians. So the angle is changed to theta plus or minus pi radian. This indicates that the vector A is being inverted. Now, cos of 180 plus theta is minus cos theta. Therefore, this third term will become negative. For that reason, you are getting the answer as A square plus B square minus 2AB cos theta. So, if the sum of the two vectors is having the magnitude this much, A square plus B square plus 2AB cos theta, then the magnitude of the difference of the two vectors is written as A square plus B square minus 2AB cos theta. Again, one situation is also possible. Suppose vectors A and B, these two vectors are having same magnitude, but they are pointing in different directions. Of course, some angle is subtended between them. Some angle is subtended between them, but they are having the same magnitude. That means A square is equal to B square. If you substitute like that, then the sum of the resultant vector will have the magnitude this much, A plus B. A square plus A square plus 2A square cos theta, where addition of these two together will make 2A square plus again 2A square cos theta. Then this 2A square being common, you can take this outside of the root, then you'll get root 2 of A into under root 1 plus cos theta. Then cos theta can also be written as 2 cos square theta by 2 minus 1. The minus 1 and plus 1 will of course get cancelled. Then the result will become like this. Now again root 2 you can multiply with again root 2. Then your total answer will become A plus B. The magnitude of the sum of the two vectors is equal to 2A cos theta by 2. You have to take the half angle. Next. In these two vectors, which you have taken at the beginning, suppose one of the vector is inverted its direction. If one of the vector is inverted in this direction, then in this equation, you have to use here, instead of plus, at the third location, you have to take minus, like this. I have shown here, again, this equation where the difference of the two vectors is having certain magnitude and you are interested to write the magnitude. At the third place, you have having here negative, so the same will continue. Again here, under root of 1 minus cos theta is written as under root of 2 sine square theta by 2. So your final answer will be like this. So this is the conclusion. And finally, at the end, I'd like to add one thing here. Suppose several number of vectors are given where all the vectors are able to be drawn in the form of one polygon. Let me draw here like this. Okay. See here, this is one vector, this is another vector, this is another vector, and this is another vector. Totally, you are having 4 vectors. One vector is moving in a clockwise direction. Other vector is also moving. Other vector is moving in anti-clockwise direction, and this vector is moving in clockwise direction. And this is moving in anti-clockwise direction. Okay, this is moving in clockwise direction. So you consider here several number of the vectors. And the names of vectors I'll write here. The names of vectors I'll write here like this. One is vector A, another is vector B, another is vector C, another is vector D. So these are the different vectors. Let me take this vector A. For example, this is vector A. Right? Four vectors are like this. Another vector B I'll take here. For example, this is vector B. Next, this is vector C I'm drawing here. This is vector C. This is vector C. Next, vector D is here. And all these vectors together are forming one polygon around the round cycle. This is vector D. And let me again write here vector A. See here, totally four vectors are there, A, B, C, D. Now you see the directions, whether all the vectors are moving in clockwise direction or some of them are moving in anti-clockwise direction. If you see the directions, then you can categorize the vectors into two categories, those which are moving in clockwise direction and those which are moving in anti-clockwise direction. Then you can write one equation. You know, every equation is comprising of left side part and right side part. So all the vectors which are moving in clockwise direction, you take at one side, and all the vectors which are moving in anti-clockwise direction, you take at the other side. For example, vector A is in anti-clockwise. The vector A is in anti-clockwise direction. B is in clockwise direction. Again, C is also in clockwise direction. D is also in clockwise direction. That means B, C, D, except A, B, C, and D, all the three vectors are rotating in the clockwise direction. Vector B, vector C, vector D. Only vector A alone is moving in opposite direction, that is anti-clockwise direction. That means you have to write the equation where A is kept at one side, B, C, D are kept at the other side. Let me write the equation like this. A is kept at one side and B, C, D are kept at the other side. B, C, D are taken at the other side. This is the equation. Okay. So the equation becomes like this. Let's write the equation here. See here, this is the equation. This is very much general principle. You can use this principle in the case of 4 vectors or in the case of 5 vectors or 3 vectors or any number of vectors. The condition is that all the vectors should be such that they should form a round figure. If all the vectors are making a round figure, then you can write the mathematical equation using these vectors such that all the vectors which are rotating in one direction, for example, the clockwise direction, to be written at one side in equation, and the vectors which are moving in anti-clockwise direction to be written on the other side of the equation. So this way we can write the equation. And next, I'll take another slide. Okay, you imagine that this is one vector. This vector is having some diagonal direction. This vector is drawn in diagonal direction. And I want to add, in addition to this vector like this, one vector I will take like this. I'll change its color. And in addition to that, I'll take another vector like this. I'll change its color like this. Now, in terms of this green and red, I can write here this is forming one triangle. In this triangle, this is one vector, red color vector, and this is green color vector. According to the principle of that addition of the vectors, you see here, green color vector and red color vector, both of them are moving in anti-clockwise direction, whereas black color vector is moving in clockwise direction, right? Black color vector is moving in clockwise direction, whereas green and red are moving in anti-clockwise direction. That means you can write the mathematical equation, and in that equation, at left side and at right side, you will write two different quantities. All those vectors which are moving in one direction, you will write one side. For example, green plus red, you will write one side. And black vector, you will write at the other side. Instead of colors, I can give the names. The green color vector, if added with red color vector, the total answer is the black colored vector. That means black color vector is possible to be splitted into two parts. The black color vector can be splitted into two parts. One is green color vector and other is red color vector. If we add these two, the green color vector and red color vector, the summation of those two vectors is going to give you the resultant black color vector. That means the black color vector can be split into two parts. One part is green in color and other is red in color. And moreover, you can imagine that the green and red color vectors are perpendicular to one another. Now, there comes one concept of component. Two vectors which are perpendicular, and the two vectors when added, you are getting one resultant vector. Then those two vectors are called the components. Here, red and green color, these two vectors, when added, the result is the black color vector. So black color vector is supposed to have the two components. One is green in color and other is red in color. So this is the concept of the components of the vector. By this, I'm going to close the session. I hope the session is helpful to you. Thank you.